Hello, this is Kamele, and we're doing number 8. And it says, if I push on a 1 kilogram book with a force of 100 newtons, I can hold it at rest against the wall. Find the coefficient of friction between the book and the wall.
All right, so in this question, we have the book against the wall, which is this diagram to the right. If the book is pushed against the wall, our force of gravity is still going to be pointing downwards. But now we have to see, since this is a book against the wall, it's no longer on a table. We have to push hard against the book with an applied force to keep it up. The reason why the book doesn't fall through the wall is because the wall actually pushes back on the book. So when that happens, that is a support force, which we call the normal force. And the normal force is no longer pointed up. It's actually pointed to the left. And then since the book is in contact with the wall, and it is opposing where the book wants to go, which is down, we have an opposite force called the force of friction. So in this case, this is a free body diagram that is not a book on a table, it is a book on the wall. In this case, our mass given is m is equal to 1 kilogram, and the force applied is equal to 100 newtons. FAPP is equal to 100 newtons. If you look at this free body diagram, the rightward force actually equals the normal force. So FAPP in this case, Fn is equal to FAPP. If we keep on going and looking at filling out this free body diagram, we know that the force of gravity and the force of friction have to also be the same. And we actually have an equation for the force of gravity. The force of gravity is equal to mass times the acceleration due to gravity. Using our givens, we know that the acceleration due to gravity is estimated at 10 meters per second squared. So we have 1 kilogram times 10 meters per second squared. And you get a force of gravity that is actually equal to the force of friction to be 10 newtons. The question asks for the coefficient of friction to be a question mark. The equation for coefficient of friction is the force of friction divided by the normal force. So once you plug everything in, you get 10 newtons divided by 100 newtons of normal force. You get a coefficient of friction of 0.1.